Thank you. So once again, good day, everyone. Happy to show what we are doing with SSAIL technology for flexible circuits. And quick introduction into Akoneer, what we do. So we do laser machines, laser machine integration for your typical laser micromachining applications like drilling, cutting, engraving, etc. Focusing on mostly ultra short pulse laser applications, femtosecond lasers. We have been doing that for 13 years. And for last year and a half, we are focusing quite a lot on the SSAIL application, which is selective surface activation induced by laser. And that's a technology that was developed in Center for Physical Sciences and Technology in Vilnius, Lithuania. It's a patented technology. How to well, let's say, print the electronics on pretty much any dielectric material. So how the process itself works, as the name of technology suggests, of course, we have a laser included. So first we have laser surface modification. Then we start the chemical process. We have chemical activation, we have electrolysis plating, and then we get the final part. And for some of you, the process might seem quite familiar because it's very similar to LDS, or laser direct structuring process. And that's true, but it has one very major difference. Because for SSAIL process, we don't need any additives in the material itself. So no metal additives, pure polymers, ceramics, glass, etc. All of that is possible. And that obviously brings some new capabilities and new advantages with that. Of course, just using the standard materials, but also no change in material properties. These are mechanical, chemical, electrical, etc. We have tested a lot of different materials, and that's definitely not an exhaustive list. We test new materials every 2 weeks or so. And some of them are proprietary ones. We work with some adhesive companies that do semiconductor packaging materials. We work with many different glasses, polymers, ceramics, silicon even. And the form factor can be from 3D shapes to thin films, because the effect to the material that we do with the laser is very delicate. So even really thin films can be used. As for resolution of the process, fast process goes down to about 10 to 15 microns on most of materials. With that, and that around that trace width, we switch to a slower process, and then we can go down to about 1 micron on some materials. Let's say less than 5 on most of them. And still, even with our slower process, we still have tens of millimeters per second, or sometimes, if lines are longer, hundreds millimeters per second of traces on the material. And yeah, with that also comes other things that can be done. For example, transparent conductors. Instead of using ITO, we can do a metal mesh with lines that's below 5 micron of copper. It's invisible to human eye without any other devices. And overall, transparency of such metal mesh is even better than, let's say, ITO. The transparency reduction is about 1 micron for the pattern printed here on PET. As in my topic of the talk, I promised you that it's a fast development process for flexible electronics. So let's get to the process a little bit. And development is really fast, because when we get